Welcome back to my channel. I hope everyone is doing great. Let's solve today's Leetcode problem 3650 minimum cost path with edge reversals. You are given a directed weighted graph with n nodes labeled from 0 to n minus 1 and an array edges where edges of I contains ui, vi and wi representing the directed edge node from ui to vi with cost of w1. Okay, so this is u and v and this is wi. Okay, each node ui has a switch that can be used at most once, where you arrived at ui and have not yet used its switch. You may activate it on one of its incoming edges vi to ui, reversing the edge from ui to vi. Okay, if there is a node and if there is an incoming edge to it, then you can actually reverse it. Okay, that is what they mean. Okay, the reversal is only valid for a single move, and using reversal edge costs 2 times wa. Okay, so if there is a node, if there is an edge from 0 to 1 whose cost is 3, if I reverse this edge, then there will be an edge from 1 to 0 with a cost of 3 times 2, which is 6. Okay, you can imagine a one more edge here which is of cost 6. Okay, because we are reversing this edge and the cost will gets doubled. Okay, here the minimum total cost of travel from node 0 to node n minus 1. If it is not possible, then it 1. Okay, assume that there is no reversal and all this stuff. Assume that there is a simple graph. Okay, and you want to identify, given this weighted directed graph where all the weights are positive, now you want to find the shortest path from a particular source node to a destiny node. Then how we can do it? Yes, if you answered it as Dijkstra, then you are absolutely correct. Okay, using Dijkstra algorithm, you can find the shortest path from shortest distance from a source to all the nodes, all the destinations. Okay, so if the source is 0 and if I apply Dijkstra algorithm, I can identify the shortest path to reach 1, shortest path to reach 2 and shortest path to reach 3. Okay, assuming that there is no extra constraint. Now they have kept a constraint saying that, not this constraint, they added a one more extra functionality saying that you can at most reverse a particular edge. Okay, so assume that there is a one more edge over here. If I choose to reverse this edge, if I choose to reverse this edge, then will be one more edge over here. If I choose to reverse this edge, then will be one more edge over here. And if I choose to reverse this, then one more edge over here. So there are many possibilities. Okay, either I only choose to reverse this edge, then there will be one possible answer whether I can reach to 3 or not. If I choose to reverse this edge, then there may be, that may be resulting to my shortest path. Okay, to reach from 0 to n minus 1. Okay, we don't know exactly. So what we do is we basically keep all the reversed edges in a given graph and then we apply Dijkstra algorithm. Okay, so Dijkstra algorithm is always greedy. Okay, since the edges are always positive, if there is a one more edge over here, that will not create a harm for our Dijkstra algorithm. The reason being, we always choose the shortest path, shortest edge. Okay, we always choose the shortest, the nearest path, short weight edge from a source, and then we basically update the distances in a greedy way. Okay, so let me explain once again. Okay, so if you see, the shortest path to reach 1 is, the distance cost associated to reach 1 here is 3 and cost associated to reach 2 is 3. Okay, now among these two, I using Dijkstra algorithm, I always choose this node to further explore. Okay, reason being, if I choose the shortest distance, then only the distance to reach my source, uh, distance to reach my destiny will also be smaller. Okay, you can think in this way. Okay, 2 plus some number or 3 plus some number. Okay, always the number with lesser weight will always leads to the shortest distance. Okay, okay, you can think it as a shortest distance. Okay, so here if you see it is 4 and here it would be 3 plus some number. Okay, so that's how we the Dexter algorithm works. Okay, Dexter algorithm keeps track of the shortest distance to reach all the nodes, and it always chooses the node with the shortest distance and further explores the neighbors of a given node. Okay, so let me show you how exactly the code will look like. If you already aware of Dexter algorithm, then you should be able to solve this problem right away. If not, anyhow I will be showing you the code. Okay, so in the Dexter algorithm, what we require an adjacency matrix, and also we also keep track of distance from the source to all of the destinations. Okay, what was the shortest distance so far we have calculated, right? So I just define an empty hash set. Okay, you will get to know why I have choose this empty hash set. The reason being, there was one test case initially. If you choose list, that is well and good. Okay, let me show you with by choosing list itself. Okay, so in regular Dexter algorithm we always use list of lists, but I have used list of set, that I will get to know. I will show you in the code. Let's assume that we have used list of list. Okay, so this actually means for a given node v, okay, for a given node v, what all neighbors I have, that is what this adjacency matrix will store. Okay, for v, what all nodes we have. Okay, so I've just defined for each node empty list. Now that I was traveling through all the edges and I'm populating my adjacency list. Okay, so for v, I have a neighbor which I'm storing in terms of pair, where v is the neighbor and w is the cost associated with that particular edge. Okay, so where I have defined a pair as it contains two fields v and w. Okay, I have a constructor over here which will set these fields, and then I have defined a method called get weight, which will basically return the weight. Okay, so you will get to know why I have used this, why I have defined this particular function in before in the code. And I also mentioned that we'll also have a reverse edge. Okay, that means I mentioned that we will be reversing all the edges. We'll assume that we are reversing all the edges, and keeping those edges in place, we will try to find the minimum cost associated to reach the destiny node. Okay, so now that I have populated all my adjacency list, in the Dexter algorithm we basically have a periodic. As I mentioned, we are approaching in the greedy way. Okay, so we will always choose the neighbor which is nearer to my, which is closest to my source. Okay, so using priority queue, i'm 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 basically having elements in the priority queue based on the weight. Okay, so priority queue internally keeps the elements sorted in on the basis of weight, so that the every time I poll, I always get the pair which is closest, which is smaller in weight. Okay, so initially I've just defined the distance to reach from 0 to 0 is the cost to reach from 0 to itself is basically 0, right? That is what I've defined. I just added that into the priority queue, and then as long as my priority queue is not empty, I will just poll the element from the priority queue, and if the element which I've polled, if it is my destiny, the final n-1 node, then I just have to return the cost associated, or else I would first check. Okay, I would first check the node which the pair which have polled from the priority queue, whether the shortest distance to it was already calculated or not. If the shortest distance to a particular node, if it is already calculated, there's no point of calculating it further, right? So I will just skip it. Okay, if the shortest distance to a particular node is not calculated, that means this is the first time I have polled the element. That means this will be the shortest distance to this particular node. Okay, the shortest distance to v is basically the w so far. Okay, now I know that, now that I know the shortest distance to a particular node, now I have to update the shortest distance to all the neighbors of these nodes. Okay, so what I will do, I will loop through all the neighbors of the current node and check whether the shortest distance to those nodes are calculated or not. If the shortest distance to all the neighbors of this is not calculated, then I will just offer those elements to my priority queue, saying that the cost associated to reach that particular neighbor is the current node weight the distance to reach the colored node plus the distance to reach the neighbor, which is the edge of the neighbor. Okay, the shortest distance to reach this node plus the weight would tell me the shortest distance to reach this node. Okay, from 2 to 3. Okay, now that I have offered this element into the priority queue, now this loop will keep on run as long as my priority is not empty and as long as I have not reached the n minus 1 element. Okay, if I have reached n minus 1 element, that means uh, the minimum cost to travel the particular node is calculated, that will be returned. If we are not able to return here, and if all the elements were already processed, that means there is no way I can reach n minus 1 node, so I will be returning minus 1, which stated in the problem statement. Okay, so let me run this problem. Okay, as you can see, there will be one test case which will be failing. Currently it is not there. Let me submit this solution, then you will be able to figure it out. Okay, it's well and good, all the test cases were passed. So there was a use case where I was actually facing an issue where all the test cases, there were duplicate edges from each node. Okay, so there was, that was one use case where it was failing. You can use actually set or adjacency list, set or array list, anything is fine. If you use set, that means the duplicate nodes will not be a part of the adjacency list. Okay, the I mean, if there is an edge from 0 to 1 and if there is another edge from 0 to 1 which is of again 3. Okay, if adjacency list contains two different elements of 0 1 3 and 0 1 3, then keeping it as a set will at least make sure that the adjacency list will not contain duplicate edges. Okay, that is one approach, okay, which you can also take. Yeah, that's all about this problem. If you like the explanation, if you understood, uh, if you have seen all the way through, that means you're liking the content which I'm trying to post, and I highly recommend you to subscribe to my coding channel. And if you have any feedbacks, you can share me in the comment section. Hit the like button and also comment how do you feel about the video explanation. Thank you.